Lesson 7.1, Electric Charge. Electric charge comes from the atoms. In the nucleus of the atom, we have protons, which have positive charge, and neutrons, which have no charge, but the same mass as the protons. So they're all jumbled together here in the nucleus, which is this tiny little part of the atom. Around the nucleus, we have the electron cloud. An electron has a negative charge, but very small mass. So these are all little electrons here, orbiting around in the different shells in the electron cloud. The charge of an electron is negative 1.60 times 10 to the negative 19 coulombs, which brings us to our unit of charge, which is a coulomb, capital C. And that is the smallest charge discovered, which means electricity is quantized. It comes in discrete numbers. So you can't have half of a charge or a quarter of a charge. You get one charge or many charges, but no fractional charges. The elementary charge is the absolute value of the charge of an electron, which we'll call E, 1.6 times 10 to the negative 19 coulombs. In nature, atoms have no net charge. That's because in nature there's the same number of protons as electrons, so they all cancel out. The positive charges of the protons cancel with the negative charges of the electrons. The proton, if you're curious, has the charge of positive 1.60 times 10 to the negative 19 coulombs. The same charge as an electron, just positive. So how many electrons does it take to make a charge of negative 4 times 10 to the negative 6 coulombs? Well, I think we could just take our charge and divide it by the charge of one electron. So the charge of an electron. And when we divide those, we get .5 times 10 to the 13 electrons. Wow, that's a lot of electrons. But what's their mass? So the mass is going to be the 2.5 times 10 to the 13 electrons times the mass of one electron and we put that in the calculator. And we get 2.28, if we round, times 10 to the negative 17 kilograms. That's very tiny. A lot of electrons, but very tiny mass. We have something called the law of conservation of charge. During any process, the net electrical charge of a closed system remains constant. Closed system means nothing goes in or goes out. So everything stays the same amount inside. So our charges aren't being created or destroyed. For example, if you rub a balloon on your hair, the balloon is going to steal electrons from your hair, which means the balloon gets a negative charge and your hair gets a positive charge, but the total amount of charges stay the same. Like charges repel. So you rubbed the balloon on your hair, So the balloon is now negative, your hair is now positive. Since your hair is positive, they want to get as far apart as possible. And so that means they're going to stand on end to get as far apart as possible. Unlike charges attract, the attraction and repulsion are forces and can be used with Newton's laws and other dynamics problems. So the balloon is negatively charged, which means it sticks to the wall or the ceiling, which are neutral charges. Technically, it's going to be attracted to the positive charges at the surface of the other object, so the opposite charges are attracting. A use of this is electric ink, or e-ink, used on some reading tablets. So what they have is they have these little microcapsules, and they're full of beads and a colored fluid. Those beads are charged. So we have a little base layer underneath, and when that base layer is positively charged, the beads are attracted, leaving just the dark layer for you to see. But if the base layer is negatively charged, it repels the beads and you see the white beads. And for each pixel, you can change the charge. Electricity can flow through objects. Conductors let the electrons flow easily. Most heat conductors are also electrical conductors, and the best conductors are usually metals. Why metals? Because they have these valence electrons that are very loosely held on. So these little electrons can go wherever they want and aren't closely tied to any particular nucleus. However, insulators are poor conductors, such as rubber, plastic, or wood. They hold on to their valence electrons very tightly, so they don't let them move much. The most common way to charge something is by contact. So in this case, we have an ebonite rod that's negatively charged. It touches a metal sphere. Some of those electrons flow from the rod into the sphere. And now the sphere becomes negatively charged because it has more electrons than protons, and the electrons flow until the charges are equal. Static electricity charging: when two insulators are rubbed together, one will steal the electrons from the other. So it becomes negatively charged, and the other becomes positively charged. For example, here I take this balloon, which is a rubber insulator, and rub it on the sweater, which is also an insulator. And notice, we've grabbed all these, the balloon grabbed all the electrons, the sweater stayed positive, and if I let it go, it's attracted to it. Also notice when I move it by the wall, the extra electrons repel the electrons in the wall, leaving just positive charges by the balloon. So the negative charges on the balloon are attracted to those positive charges on the wall, and the balloon sticks to the wall. We can also polarize atoms in insulators. The electrons are not free to move around. They are stuck with that atom. They don't, the nucleus holds on to the electrons very tightly. But when a charge is brought near, so we have this negative external charge, it's going to repel the electrons in that atom to the other side. Or if it's a positive external charge, it will attract the electrons to the other side. Either way, this side of the atom is positive and this other side is negative. That's polarized when one side's positive and the other side's negative. we can use that basic idea to charge by induction, which is charging without touching. So we have two spheres. They are touching each other and they are both neutral. It's a metal sphere on a plastic rod, so it's an insulated metal sphere. A charged rod comes near one of the spheres. In this case, it's a positively charged rod. And so what it does is it repels the positive charges to the other side. Technically, it's going to attract the electrons to the positive charges. And so that means one sphere is negatively charged and the other is positively charged. So we separate the spheres. And so one stays negatively charged and the other is positively charged after the rod is removed. Notice we had to separate first and then remove the rod. And that left them. If we remove the rod first, the electrons would flow again and both spheres would be neutral. So separate the spheres first, then remove the rod.